Hello, and welcome back to the channel. Today we're going to walk through how to build your own weather radar app. I'll walk through each piece of the architecture and where we're getting the data from and how we convert it into radar data into pixel data. I've been wanting to build something like this for a while. Today's session's kind of a show and tell. I used to ambush the NOAA booth at, I want to say it was the Esri conference in San Diego each year, and each year I'd get a little bit closer and closer to uncovering how to build this. There's a lot of details in how this data gets from these radar stations, and made available to the public, and it was always hard to track down the right person who knew how it worked end to end. And I've always been frustrated with the radar maps that are publicly available, and they always have very limited history. Now, there's probably better paid ones out there, but I knew the data was there. I knew the data existed, and so I wanted to show it on a map. And so you can see here, this is my closest radar station. This one's down in San Antonio. In my research, I've learned that there's actually not very many of these. There's only a handful of these in Texas. They're usually at major airports, so I think there's one at Dallas and Houston. The airports need to have very accurate radar data, obviously, so they can track wind shear and conditions on the runway. Apparently, here in Austin, we actually don't have one at the airport. Well, there is one at the airport, but it's like a privately funded one. I think it's even funded by the local news station because they needed one for Austin too. But the closest government funded one is down in San Antonio. And so the government funded ones, basically they have to provide the data to the public. And so these things are dropping their data into the AWS Registry of Open Data. They've chosen this as where they're going to share the data. These buckets are free to access, free to download. Lots of other data sets in here, but if you go to the AWS Open Data Exchange, search for NEXRAD, you can see this is the bucket name. There's level 2 as well as level 3 data. And then we can see here too. So here's how I pull down one of these files. You just grab the bucket name and the file name. It's weird, the syntax or naming convention of these files. It's like the radar name and then the timestamp, and they all just drop into the root level bucket. So there's probably billions of these files sitting in the root of the bucket. They should probably look into partitioning this by some type of folder structure. But I mean, it's not really that big of an issue. S3 can handle billions of objects, no problem. But let's go ahead and take a look at what's actually in that file. So when you download the file, and this was one of the things I kind of struggled with talking to the people at the NOAA booth, is these are, they look like custom files. They don't even have a file extension when you download them. The first 30 bytes is like a description of the data type, the 4-letter station ID and a timestamp. And then there's a 120 byte binary that's got headers, GPS location, scan time, radar mode. The compression type's a big one too because these alternate between two different types of compression. I think it's bzip, and I forget the other one. And then you have 1 meg to 5 meg that is varying payload sizes depending on how much radar data there is. And even these 30 bytes and 120 bytes are variable, so you got to go in and check and see how many bytes were actually used. There is a library, a Python library that can handle a lot of this for you called PyArt. That's kind of a larger library though. So the way I have mine is trimmed down. It's much smaller. And so with that, let's see what this looks like. So it's not very rainy today, but there is rain in the forecast. You'll notice too, these radar files are way more sensitive than what you see from the local station. So like outside there are like little drops of rain, very drizzly, cloudy, but not real like actual rainfall. So if I go to my local weather map or AccuWeather, you can see there's little dots. I should have pulled one of these radars. There's a big old storm over here. But I did take a screenshot. We had one the other day. And I compared what was on my radar to what these radars were saying. So this was what was on mine. And this was actually using the 3D data, so it was like super detailed. Looked really nice. But I'll go into that later. Those were huge files. And so that's what my radar was saying. And this is what was on the radar map. So you could see, some red spots just kind of to the east of Austin. And you can see these red spots here. This is Austin over here. And so this is my live map. That's pretty cool. And so this is all free. It's running locally. I've actually converted this now to run on AWS as an S3 bucket. This is an HTML JavaScript file. And then I've converted the Python logic into a Lambda function. And let's walk through that. Where did it go? Right here. Okay. So the JavaScript function in the HTML, we're using MapLibre for the map framework. And then there's a bunch of, this is really just like the UI controls, the slider bars and stuff. I mean, most of your logic is right here. There's actually a JavaScript function. And this is where we add the layer. It's a raster layer. So the Python function is going to convert the radar data into pixels. And then we're able to draw that on the map as a raster layer. A lot of this code, is fairly complex. And part of this video, it's crazy the times we live in AI. I've been trying to build this thing for 2 or 3 years. And then I sat down with Claude Code and Gemini over the weekend and basically built this in like an hour or two. Now there were some changes. Originally Gemini and Claude Code wanted to use the level 3 data, and they were massive files. I mean, it was pulling 3 or 4 gigs over the network. And so I had to tell it to go in and use the level 3 files, which are much smaller. So now instead of gigs, it's probably like 4 or 5 megs of data that move over the network. And originally it started with the PyArt or PyArt library, but it was too bulky, and so to fit into an AWS Lambda function, even as a layer. I mean, it was a huge library. And Claude Code and Gemini were able to basically create this radar without using that library. I mean, it's really impressive. You can pretty much build everything. Gemini and Claude Code knew about the NEXRAD bucket, that it was available on S3 to download this data set from. And then like this is kind of the crazy part too. Where's the function? So again, a lot of this Python is it's kind of creating a web server so I can run it locally. I think this is like the main function. This is what Claude Code and Gemini created, but it's doing it's a trigonometry basically to convert those digital radar signals into pixels. And then output the PNG file that you see on the map. And so I've made this available so anybody can go and download this app. I mean, or you could recreate it with Claude Code. I started with Claude Code and then ran out of tokens, and so finished it with Gemini. But I honestly, like, Gemini is really good too. And I don't know that I have a cap on Gemini. Like, it seems to have a lot of tokens. I hit my cap on Claude Code fairly consistently because I like to use Opus. But yeah, both of those are fantastic models. They handle geospatial very well. I've recreated this also with an ArcGIS map, JavaScript map. It knows both very well. And here's the GitHub repo. So Jeff Demuth, NEXRAD radar. I've got the app, the index, the requirements file. You'll just pip install that. Really just go to the app.py and run that file. Actually, I should probably show that real quick. So Python, app.py. This just starts a web server. And then this handles some of the caching logic too, because like I said, there was megs of data going over the wire. Originally gigs, but then I changed it to level 3 and now it's megs. But still, it can add up quickly, so it's better to just pull the file down one and cache it, and also be nice to the S3 bucket, because technically the NEXRAD account is the one that has to pay for those data transfer fees. So we'll try to be nice to them. But that's all I had for the video today. I'll probably do a couple more of these kind of show and tell. There's a couple other applications I've been wanting to build, and hopefully there are some people out there that weren't aware that these NEXRAD buckets existed. I think it's really neat that anybody can build their own radar app, and you have got infinite history. Basically, those things go back really far. And that's all I had for today. So thanks for joining. If you enjoyed the video, like and subscribe. Thank you.